Hi everyone. In this video, we are going to discuss about what is the necessary condition for two lines to be concurrent, meaning two lines have to intersect each other at one point, right? Now let's assume that the equations of each of the two lines are like this. Let's say the equation of the first line is a sub 1 times x plus b sub 1 times y plus c sub 1 equals 0, and the equation of the second straight line is a sub 2 times x plus b sub 2 times y plus c sub 2 is equal to 0. If you think about two straight lines, if they never intersect each other, that means the straight lines are parallel. And that is a fundamental concept from geometry, that parallel lines never meet each other or never cut each other. They never intersect each other. Now, if two lines have to be concurrent, that means if two lines have to intersect each other, then they cannot be parallel. We need to clearly understand this concept, right? That if two lines have to intersect each other, they cannot be parallel. That means their slopes cannot be equal. So the necessary condition here is that the slope of line 1 cannot be equal to the slope of line 2. So let me make a quick note here. So here I have noted that slope of L1, which is line 1, is not equal to the slope of L2, which is line 2. Now what is the slope of line 1 from this equation? Well, let's convert this equation into the y equals mx plus b form. So here the equation was like this. The first equation is a sub 1 times x plus b sub 1 times y plus c sub 1 is equal to 0. And from here we can say, well, then b sub 1 times y can be written as negative a sub 1 times x and minus c sub 1. And from here, what would be the value of y? Well, y is equal to negative a sub 1 over b sub 1 times x, of course, and minus c sub 1 over b sub 1. And here is the slope, which is negative a sub 1 over b sub 1. That is the slope of the first line. And similarly, let's convert the equation of the second line into the similar form. So the second equation was like this. This is a sub 2 times x plus b sub 2 times y plus c sub 2 is equal to 0. And we can write it as b sub 2 times y is equal to negative a sub 2 times x and minus c sub 2. And from here we can say, well, y then is equal to negative a sub 2 over b sub 2 times x, of course, and minus c sub 2 over b sub 2. And what is the slope here? Well, again here the slope is like this. This is the slope of the second straight line. So we have found out the slopes of the two straight lines, and our necessary condition is that the slopes cannot be equal. So let me kind of highlight that here. So the slope of the two lines cannot be equal. That's the necessary condition, and that is when we know that the two straight lines will intersect each other somewhere, right? Not at infinity, but they will intersect somewhere. So then can we write the condition like this then? Because the slopes cannot be equal. So now what I'm going to do, I'm going to say, well, then negative a sub 1 over b sub 1, which is the slope of the first line, is not equal to the slope of the second line, which is negative a sub 2 over b sub 2. And from here, can we write it like this? Let's do the cross multiplication here. So we will have negative a sub 1 times b sub 2 is not equal to negative a sub 2 times b sub 1. And if we multiply both sides by a negative 1, then both terms will become positive there. So then we can say a sub 1 times b sub 2 is not equal to a sub 2 times b sub 1. And from here we can say, well, then definitely a sub 1 times b sub 2 minus a sub 2 times b sub 1, if we bring the term from the right hand side to the left hand side. So this is definitely not equal to 0, and that is the necessary condition. So when we are given the equations of two straight lines, if we can quickly check this condition, and if this condition is true, then we know that they will intersect each other. That means they are not parallel and they will intersect each other somewhere. Also, if you remember the cross multiplication method of finding solutions of a set of two simultaneous linear equations, there the solution is going to look like this. For these two equations, the value of x would be b sub 1 times c sub 2 minus b sub 2 times c sub 1 over a sub 1 times b sub 2 minus a sub 2 times b sub 1. And the value of y is going to be like this. It would be c sub 1 times a sub 2 minus c sub 2 times a sub 1 over a sub 1 times b sub 2 minus a sub 2 times b sub 1. I have already created a separate video on this topic and I have shared the link in the description. Feel free to watch that video. And actually the way it works, if we have the equations like this, for example, if our equations are like this, let's say we have a sub 1 times x plus b sub 1 times y plus c sub 1 is equal to 0, and the second equation was a sub 2 times x plus b sub 2 times y plus c sub 2 is equal to 0. Then to find the solution for these two simultaneous linear equations, we can use the cross multiplication method, which is kind of like this. We have to write down the coefficients like this. So we can write them as a sub 1, then we can say b sub 1 and then c sub 1, and then let's write a sub 1 again. And here for the second equation, let's write a sub 2, then b sub 2, then c sub 2, and then a sub 2 again. The denominators of the value of x and y, they're always same, and they are actually kind of like this. So if we multiply a sub 1 with b sub 2, we're going to multiply like this, and then minus a sub 2 times b sub 1. You can remember it like this. This is why we call them cross multiplication. So this will give us the denominator. Now what about the numerator? Well, for the numerator, we have to do like this. For x, we have to leave the coefficients of x. So we have to now focus on the coefficient of y and the constant term. So if we multiply like this, let's say b sub 1 times c sub 2. So this is one multiplication here, b sub 1 times c sub 2 minus, then we can do b sub 2 times c sub 1. That would be the numerator for the value of x. And then what about the numerator for the value of y? Well, then now we have to go with c and a. So if we multiply c sub 1 with a sub 2 minus if we multiply c sub 2 with a sub 1. So it's c sub 1 times a sub 2 minus c sub 2 times a sub 1. That's going to give us the numerator for the value of y. And the denominator is always a sub 1 times b sub 2 minus a sub 2 times b sub 1. And all of these have been explained in the other video. I have shared the link in the description. Feel free to watch it. So if this is the solution, meaning if the value of x and y going to be like this, that means if we have a valid solution, that means the two lines are going to intersect each other at that point where the x coordinate would be the value of x as denoted here in the pink box, and the y coordinate would be the value of y. So if there is an intersection point for the two lines, meaning if they intersect each other at a point, that means we will have a valid value for the x coordinate of that point and a valid value for the y coordinate of that point. And if the x value and the y value have to be a finite number, then you can clearly see that we can come up with one necessary condition, which is that their denominator cannot be equal to 0. Because if the denominator becomes 0, then this becomes division by 0. That means we cannot determine the value of x and y. And if you think of it from a different aspect, like if you think that, hey, if the denominator approaches 0, then the value of x and value of y will obviously approach infinity. And in that case, the two lines will intersect each other at infinity. That means they are actually parallel. So for the two lines to intersect each other, we must have a finite value of the x coordinate and the y coordinate of the intersection point. And that means the denominator of the x value here and the denominator of the y value, they cannot be equal to 0, right? So then from here again we can say, well, here also we see the condition as a sub 1 times b sub 2 minus a sub 2 times b sub 1. This cannot be equal to 0. And if we scroll up, we see the same condition that I have highlighted right here at the top of the screen here. You can see that a sub 1 times b sub 2 minus a sub 2 times b sub 1 is not equal to 0. We derived that from the condition of slopes, right? That the slopes of the two lines cannot be equal. And from there we derived that condition. And here again from the cross multiplication method also we have derived pretty much the same condition. Let me just scroll up just a little more, and here again you can see that we have pretty much derived the same condition even from the concept of having a finite value for x and y. So in both ways we see that the necessary condition for two lines to be concurrent is that a sub 1 times b sub 2 minus a sub 2 times b sub 1 cannot be equal to 0. That means we can also say that a sub 1 times b sub 2 cannot be equal to a sub 2 times b sub 1. That can also be taken as another condition, but they both are the same thing. There is basically no difference. It's just two different look and feel. So a sub 1 times b sub 2 cannot be equal to a sub 2 times b sub 1. Or in other words, a sub 1 times b sub 2 minus a sub 2 times b sub 1 cannot be equal to 0. Then only we can guarantee that the two straight lines will intersect each other somewhere. But if a sub 1 times b sub 2 becomes equal to a sub 2 times b sub 1, that means the lines are parallel and obviously they are not going to intersect each other anywhere. Now let's take a quick example. Let's suppose we have been given the equations of two straight lines. Let's say we have 2x minus 3y is equal to 1, and then we have 3x minus 2y is equal to 2, for example, right? And we have been asked to find out if these two lines are concurrent or not. So what is our necessary condition? Well, our necessary condition is that we have to find out the value of a sub 1 times b sub 2 minus a sub 2 times b sub 1, and that cannot be equal to 0. That's our necessary condition. If we substitute the values here, this is obviously a sub 1. So let me quickly write here that this is actually a sub 1, which is positive 2, and then b sub 1 would be negative 3. And what is a sub 2? Well, a sub 2 is actually positive 3, and then b sub 2 is actually negative 2. So now let's substitute the values. So now I'm going to calculate a sub 1 times b sub 2 minus a sub 2 times b sub 1, and let's see what that value is, right? It should not be 0. If it is 0, then they are not concurrent. If it is not equal to 0, then they are concurrent. So let's substitute the values here. A sub 1 is actually positive 2 times b sub 2 is actually negative 2 minus a sub 2 is actually positive 3 times b sub 1 is actually negative 3, and that is equal to negative 4 plus 9, which is equal to plus 5, and that is not equal to 0. So positive 5 is not equal to 0. That means the condition is satisfied. That means the two lines are concurrent. They cut each other somewhere. I hope everything made sense. Thank you for watching. See you in the next video.